Welcome to Chapter 3 of WebML Machine Learning following the course, using pre-trained models. So you can find models at tfjs-models at GitHub. And here's what he has to say.
Try a live demo of each to get yourself a feel for the inputs the model expects, such as image, text, or sound, along with the outputs it provides you. Now, some parts of the documentation might seem overwhelming at this stage, but...
And he's fairly correct. Here's me trying to use Cocoa SSD, and at first I try to follow the instructions. And this is a condensed version of me doing this. And it doesn't go exactly like it's supposed to. So here we have it going, and it's a build error. But if I do it differently with npm install legacy pure deps, and then npm run watch, it works great. Now for pose detection, I haven't figured out what is holding me back from running this. So I try to do the same thing again and try to carry over whatever I've learned. And it doesn't really work out that well. So I get a whole bunch of errors eventually. And I try to run it anyway. It doesn't work. But the good thing about this one is that there is some live websites with just the models running, and they make it really easy to understand these models and what kind of backends they have. You need to select a model, and he uses the example of you want to detect somebody that is entering your garden, and he gave an example of using a sound, which is ways that I didn't think you would detect people. But if they say words or anything, it'd be very easy, and it's a lot less intensive than image processing. What are the constraints you have? So this one, he had a smartphone, and he needed to make sure that it was able to connect, and he wanted to know how fast to be. You can use the documentation for this if there is stuff, and you need to know if it's going to be fast enough for what you're doing, because you might need 1 frame per second, or you might need 60 frames per second. And then, is that model good enough? Could you choose a better model? And the easiest way he did this was with a spreadsheet. Now we make our own Cocoa SSD, and his example, it's very elegant, basically one function that contains everything. And here's mine forged in ChatGPT before I watched this tutorial. And I did learn some things. So the beginning here, we have model.detect video and then the .then function, which encapsulates most of the function. We remove the live view, which is the rendered page, and the children, which we'll add at the end. And then children.splice is a way of making an array disappear, is what he says, and I'll believe him. And in the drawing, we create 2 elements that aren't rendered yet. And at the end is where we'll do it. In the middle is where the position is set, and it's fairly straightforward. It's just knowing which one lines up to which item, and then it recalls itself at the end. My code was a lot of functions, mostly asynchronous, which I wouldn't suggest doing, and it had a lot of problems, and it wasn't made better by me putting them everywhere. Mostly because I tried making some non-asynchronous things, and it didn't really work out that well. And another element that I wanted to hit on was drawing in unrendered elements first, and then putting them in. I didn't think of that because Canvas, it's really easy. Just draw to it and then it just draws. I don't think I'll be reusing my code. I think I will just start from scratch. He tells you to go to tfhub.dev, but currently that now directs you to Kaggle. The filters are still the same. They're just in a slightly different place. What is a tensor? It has type, size, rank, and shape. The type is whether it has 8 bits or 32 bits, or whether scalar unit you are using. The size of a tensor is how many scalar units in total there are. The rank is the dimensionality, whether it's 2-dimensional or 3-dimensional. The shape is the measurement of the dimensions. So for a 256 by 256 RGB image, it'd be 256 tall by 256 wide by 3 deep. And if it's black and white, it'd be 256 by 256 by 1. You should use the TF functions because it parallelizes the tensors better. Something like tf.multiply would do better because it parallelizes and uses the GPU to do it. And the TF also has specialized functions that will adjust all the tensors. When you're programming, you need to know what a tensor is because you'll need to remove it. It stays around if you don't. I had a link in this function. Tensor output was a leak that I didn't realize was a tensor because I thought it was just an array and it didn't stay around in the function, so my memory was just going through the roof. But this is the example of the advanced pre-trained models, and we use a tf.browser.fromPixel, and this makes it really simple to take images from elements. And tf-slice just takes from that one the correct slice that we need. So we take a slightly larger image. This is the picture of the lady, and then we resize that. The reason we resize it is because we're using a different function, movenet.predict, instead of movenet.detect, which I believe is different. There is a tf.expand dims, which I have no idea what it does. It's just there. And at the end, I've removed all the tensors because I changed it where I was trying to detect a video. So making a web server is fairly simple with Python. It allows you to load videos and pictures, and it's a little easier to find if you just type in localhost. It's easier than finding the web page through your browser. And it's really easy. So Python m -m http.server. And thank you for watching.